the first very important thing I've got to do is take a selfie with you all to convince my colleagues that I was actually here. So if you can pretend that you're all having a great time, I'll try and get the bit with most people in. There we go. I'm not in that one. There we go. Something like that. That'll do. Okay, so my name is Robin Moffatt. I work for Confluent. Out of interest, who's heard of Confluent before you saw my T-shirt? A few of you. And who's heard of Kafka? Oh, cool. That's quite a few of you. And who's using Kafka? A few of you. And if you're using Kafka, are you using it like Kafka Connect or Kafka Streams or just like PubSub? Just PubSub. Okay. So what I'm going to talk about today is Kafka. I found this cool picture when I was putting the slides together earlier. I should have been writing the slides, but I was actually just looking for cool pictures. All about how Kafka fits in systems that we build. Because Kafka, it's fairly well known. Like most of you said, yeah, I've heard of Kafka. But people use it for lots of different things. And some people think it's just for one particular thing or it's just for another. So what I'd like to talk about today is how Kafka acts as a platform on which we can actually build a lot of different things and explain some of the capabilities of it and why it's actually so relevant to a lot of architectures that we build out. So Kafka itself is a streaming platform. It's a streaming platform, and that's a new category of technology. It's not a database. It's not a PubSub message queue. It's a streaming platform. And the reason we come up with that is not just to be bloody awkward. It's actually because there isn't a definition of a category which exists, which describes what Kafka does. So it's a streaming platform. I'm going to explain what a streaming platform is in a moment. But I want to kind of give an example first of like, why might we care about a streaming platform? What kind of things do we do nowadays where actually a streaming platform would be kind of relevant? So why do we need one? One of the key things, certainly architecturally, that Kafka does for us is decoupling our systems. This idea that you don't have to link somewhere where you've got data to somewhere where you want to get data directly. So somewhere kind of close to my heart, because this was my background before Kafka, is analytics. And in analytics, back in the beginning, way, way, way back ago, and probably nowadays as well, we started building these data warehouses. We say, well, we've got data sat in an operational system over here. We want to query it, we want to report on it, but we don't want to impact that, so we'll copy it over there. And so we copied it over there. And then someone said, well, we've also got data that sat in this operational system down here. We've got inventory data. So now we'll copy it over there. Obviously, we're on batch jobs to do this, maybe once a month or once a week or something. But the data that we copied into that data warehouse was just a copy of what we had. So it was probably normalized. It was optimized for writing to rather than read. And maybe it was messy. It needed certain transformations. So we would build transformations on the data warehouse. We would either transform the data in flight and call it ELT, or we would transform it once it got there and do ETL. I've got that the wrong way around. ETL is transform it on the way. ELT is load it and then transform it. The point is you do a batch extract, and then you transform it to conform your dimensions, to apply certain business logic, to denormalize the data, to optimize it for performance. And this is how we do and did analytics and data warehousing. And then people started coming to these conferences and people started talking about big data. And then we said, data warehouses are old-fashioned. What you need is a data lake. You need to have Hadoop. You need to build yourself a data lake. So people started copying what they had in their data warehouse and putting it into a data lake. I'm being somewhat facetious. Obviously, big data helps us out in terms of scale. But sometimes people do these things just because they do. But anyway, we have a data warehouse. Let's copy it into a data lake. Or let's actually replace our data warehouse and take our data from our source systems and copy it into our data lake. But then, of course, we still need to transform it. So now we need to write a Spark job or something to transform that data that sat in the data lake. So this is good and fine, but it's all batch-driven. We're taking a copy of the data, we're waiting to collect it once a week or a day or something like that, and then we copy it over there. Even if we start getting fancy and doing intraday ETL, it's still kind of like half an hour or 15 minutes, and it's a batch of data. And the key thing about batching data is that we're building latency in by design. Okay? And you may think, well, that's okay. And I want you to make a mental note of this slide, because I'm going to come back to it later, because I did this talk, or a version of this talk, recently, and I got some really interesting feedback afterwards, which I'm going to try and develop on. But for now, it's all about batch and the latency that we have as part of batch by design. So batch and latency is one of the reasons why we need to change, or why we consider changing how we do analytics. Another is simply that the world has moved on. In the old days, we had data from a POS system, we had data from a warehousing system, and it was pretty small. It was like, well, the biggest was when we started talking about basket data maybe in retail, and like, what were the items within the basket? And that kind of like blew people's minds. And now we have Internet of Things, we have devices all around us. We have mobile phones. There is so much more data that we need to start thinking about. We start to architect our systems differently. We have microservices, so how we exchange our data actually changes. We have data being used to drive applications on mobile, and because it's mobile, the user is there, so there's much more responsiveness needed in the data. And then we have data that we want to use for machine learning, for training models, or taking those models and applying them in real time to the data that's passing through our systems. So the world has moved on from batch. The other reason we need to start thinking about changing how we design things is that whether you like it or not, and not everyone does, there are a lot of new technologies coming into play. And this is not a case of replacing X with Y. It's a case of, like, we've got X, and we've had X for 10 years, and we're still going to have it for another 20. But in the meantime, maybe we're going to start looking at these ones over here, and a bunch of different departments are going to have their skunkwork projects looking at this over there, that on AWS, this little skunkworks project down there, because technology is being made more available. It's no longer the kind of like the domain of just a central IT division. And that's generally a good thing. Generally, it means we can get more things done more quickly. The cloud's an obvious example. You swipe your credit card and off you go. But it means that we need to get data into those other systems, and sometimes it means we get data out of those systems as well. If you've got a political organization and someone says, my team here have developed this thing, and we need data from over there, you can't say, this is my data. You can try, and that's what central IT tries to do, but ultimately you'll get overridden and quite rightly get the data over there. And sometimes they'll do something with that data, and that manager will say, this is now how we report on this at the board level, so now you need to get that data from there back over to there. And this is whether you like it or not. This is just pragmatism. This is how it goes. So if you're not careful, you end up with this. And this is the canonical spaghetti picture. So this is where you have all of your separate databases, all of them connected to the particular applications that they're underpinning, data being exchanged between those different databases in batch fashion. You may be trying to bolt on a messaging queue or a NoSQL store to try and do bits of real-time elements around it. You're trying to maintain a data warehouse and probably a data lake as well. You want to have some search replicas. You want to do some graph analysis. All of these things become tightly interconnected and a tight mess. Because it's tightly coupled together, you've got all these point-to-point connections, it's very different to scale. It's very difficult to be able to evolve it, because as soon as you want to change one piece, all of those pieces that are hanging off it or depending on it, you have to change those or make them aware of it. So it becomes very difficult to change it. So this is where a streaming platform comes in. Kafka is a streaming platform, and it enables us to integrate all of our sources of data with all of our users of data. So a bit about myself, as I say, I work at Confluent. I'm a developer advocate, which means I get to do cool stuff like this. It's about talking to developers. It's also about listening to developers. So like we've got product teams and engineering teams who are building these great things, and I'll talk about kind of what it is. But the feedback from developers on like, here's how you could make it even better is also a key part of it. Before working at Confluent, I worked at an Oracle consultancy doing analytics and data warehousing and big data type stuff. So that's kind of my background in this. I'm proud to be part of the Oracle ACE Director and Developer Champions program. I like blogging. You can see some of the stuff there. And I like tweeting as well. So if you do the Twitters, feel free to follow me. This slide and all the other stuff is on Speaker Deck. So feel free to take pictures as you go through. But you can also get all the slides on this afterwards. So we said that Kafka is a streaming platform. And we talked about one of the reasons why a streaming platform is kind of useful. But now let's talk a bit more about what a streaming platform actually is. And to do this, I'm going to use this idea of three lenses, of three different ways of looking at it. And the reason for this is that as a platform, it's kind of tricky to nail on one particular thing that describes its entire capabilities. So let's look at it in 3 different ways. One way is that it is about messaging done right. Another way is about building out scalable streaming data pipelines. And the other is as a foundation for stream processing. The other reason why it's useful to approach it from these 3 different ways is that people come into contact with Kafka in different ways. Okay? Generally, when you want to use a relational database, you'll do so because you want to store stuff relationally and work with it. So everyone coming at a database knows what a database is because that's what they're doing with it. Whereas with Kafka, some people will use it perhaps for this one, for messaging. So they'll say, I'm using Kafka as a pub sub queue. I know what Kafka is. But Kafka is also these other things. Or people will be building out maybe big data, analytical solutions, and using Kafka for building these streaming pipelines. And they'll say, I know what Kafka is. And it is that, but it's also these other things. So the first of these, messaging done right. So Kafka is fundamentally about pub-sub messaging. You send events to it, and consumers can read those events. So there's a ton of other messaging queues out there, pub-sub solutions out there. But what sets Kafka apart from those is several different things. One of them is its great scalability. So it's a distributed system. So it is distributed, which means that you just scale out horizontally. As you want to increase your capacity, as you want to increase your throughput, you add in more brokers and you just scale out. Your data is sharded across it, you get redundant copies of it, so if you lose a node, that's fine. So it has this scalability characteristic, which oftentimes, that in itself, is enough for people to replace other systems with Kafka. It's like, hey, it's an open source project, it scales like heck, done. But Kafka then starts to really differentiate itself from other solutions because it persists data. It has persistent storage as part of its design. Kafka itself is a distributed commit log. It's an immutable event log. So you write your events to Kafka, and that log is actually persisted on disk. It's not like there's a database somewhere or something like that. How Kafka works is a log that is persisted. And that storage gives you some fantastic potential. It means that you can reread messages. It means that other applications can come along after the event and read those messages that someone else has already read. There's no idea of like transient messages, and when someone's read it, then quick, it's gone. Okay? It's not temporary or transient. So the data is persisted. And the data is also available for real-time processing within Kafka. So Apache Kafka has stream processing capabilities built in. So it is like messaging, but it's messaging done right. The next aspect is around building out scalable streaming data pipelines. This is another of the things that people sometimes use Kafka for and think, well, that's all it's for. But Kafka itself can be used for integrating many, many different systems, streaming the data into Kafka in real time, landing the data out to a target downstream. But this is where we start to get into the point of it architecturally. Because the data that we're streaming in for other systems to go and land downstream, that data is now passing through Kafka. That data is persisted in Kafka. That data can now be used to drive other applications in real time. So we think, well, we've got data that's sat in various different databases around the world. We want to get that data and go and stick it in our data lake. And we want to do so in a scalable manner. We'll use Kafka for that. But that data that's coming in from those databases in real time could also be driving other applications. Or you could be landing it out to other data stores. So it's not just like a one-to-one connection or a one-to-many. It's actually many-to-many. It's more of a circular picture than a linear one. And then the third aspect of Kafka is a foundation for stream processing. So Kafka itself has got the Kafka Streams API as part of it. And there's also the open source KSQL project from Confluent, which is a streaming SQL engine for Apache Kafka. I'm going to talk a little bit more about this later. But however you do it, is that you can actually process your data as it flows through Kafka. So you have events flowing in from anywhere. You can filter those events and create a derived stream to go and then be processed. You can aggregate those events using stateful aggregations, and you can join them as well. So this gives us the streaming platform. This is what Kafka is. It's not just about messaging. It's not just about pipelines. It's not just about stream processing. It's actually all of these. And if you think about the kind of systems that you build in your businesses, having that data available to multiple different systems in real time in a scalable manner that you can then integrate with lots of other places that you can use for pub/sub messaging as a message broker, but that you can also apply stream processing to, is very, very powerful. So it's real-time, it's scalable, and it lets you build things out in a very decoupled manner. So I've been talking a lot about streaming, and a bit about events, and event-driven, and things like that. And one of the key things is, all of our data is built on events. Whether you believe it or not, it actually is true. I'll be interested to argue it with someone afterwards. But all data is event streams. And this matters because when you start thinking of it this way, you understand the importance of using a streaming platform as the foundations for your architecture. So things like customer interactions with your business, these are events. How you store them physically is an implementation detail, but these are events. So are sales, transactions, someone buys something, that is an event. Maybe you store it as one item or whatever in your database, that's just a detail, but it's an event that caused it. But you have technical events as well. You have readings from sensors, you have log entries from an application. These are also events. And then we get onto databases. And people think, databases are events? So just hands up who's like a DBA or a SQL developer, database type person. Come on, you can admit it. I was a DBA as well, isn't it? Yeah? Okay. So a few of you. So databases don't lend themselves, obviously, to being events. Or maybe they do, but I want to explain it in a bit more detail, just in case you're not convinced. So you may think you've got a database and you're querying it, and it's just a table, and it's static, and it's just a lump, it's just an object. But actually, tables themselves are comprised of events. So if you think about a bank account, you've got a bank account, and a bank account has got an ID, 1, 2, 3, 4, 5, and it has got a balance. So the balance for a particular key, let's say it's 50 euros. But that bank account, so this is our table here, okay? So we select star from bank accounts, where ID equals 1, 2, 3, 4, 5, it's 50. That came about because someone deposited some money. An event happened. And then someone deposited some more money, and now our balance changes. So when we select against that table, it has got a new value for that key. And then we spend some money, and the balance changes again. So what we actually have is a stream of events, and we have a view of the state at a point in time, which is the database. If you think about it, relational databases work like this already, whether you like it or not. This is called the stream table duality. Because what I've just described there, it works both ways. If I change that table, that change is an event. That is your transaction log in the database. Yeah, that's how databases work. So this stream table duality is super important because what it means is, as stuff is happening in databases, we can extract that into an event stream. As we have an event stream, which is what Kafka is, it's an immutable event log, we can manifest that into a database at any point we want because you have the raw building blocks for it. So Pat Helen says it much more articulately than I do, but the truth is the log. The event log is the fundamental building blocks on which all of our data exists. Database is just a cache of a subset at a particular point in time. And once you start thinking about this idea of databases are what make the world go round, around which everything orbits, starts to get challenged a little bit. Because actually, so long as you have your event log, you can rebuild any state you want at any point in time. Okay, so let's dig in under the covers a little bit. Kafka itself, as I said, is a distributed commit log. So you have something called topics within it. Topics are kind of like database tables. Topics have messages, which are kind of like rows of data. The actual data in Kafka is just bytes. Okay, so it's format agnostic. You can put whatever you like in there. There are various serialization techniques like Avro and JSON and so on, but it's just bytes at the end of the day. You can get data in and out using the APIs that are provided. There's a bunch of open source libraries, so if you're writing your application in C, in Python, in Go, in whatever, you've got native libraries there for integrating with Kafka. But if you've got data that's sat in other systems, you've got the Kafka Connect API. So this is the integration capabilities of Kafka itself, of Apache Kafka. It's configuration file driven, and you simply point it at where you want to stream your data in from, or you point it to a Kafka topic and point it to where you want to stream your data out to, and it does that integration for you. And it lets you scale out that. You can build it as a cluster and distribute it and so on. It is fault tolerant. It manages your schema. It manages serialization. So for heaven's sake, if you're building systems around Kafka, and you're landing data from Kafka into HDFS, or you're streaming data from a database into Kafka, please don't go and write your own program using those APIs, because you'll be reinventing the wheel. Okay? Use Kafka Connect. It solved that problem for you already. Kafka Streams API is part of Apache Kafka. It's a Java library that you can integrate with your applications, which means that you can actually deploy stream processing however you like. However you deploy your existing Java applications, same with Kafka Streams. You can deploy it bare metal, Kubernetes, Docker, do whatever you want. And it's built on top of Kafka, so you get all of those elasticity and scalability guarantees, default tolerance, and so on. Building on top of Kafka Streams is KSQL. So KSQL is open source. It's from Confluent, and it's the streaming SQL engine for Apache Kafka. It is super cool, because it means that you can do things like this. You can create derived Kafka topics, taking an inbound stream of data in real time and applying a predicate to it and creating a derived stream. This is not a database query that runs and then you're done. It's a continuous query. So it creates this derived stream of data. So it could be we've got syslog data coming in from like hundreds of different machines all over our network, and we want to filter for a particular type of event. You can just run that. That's a SQL file that you can literally run on a KSQL server. That's all. You don't need to write a bunch of boilerplate code around it and so on. You just run your KSQL server. You can run one. You can run a cluster of them for throughput, and then run that against it, and now you're transforming your data. You can join your data. You could have an inbound stream of clicks on your website, which has got a foreign key out to your customers that are stored in a database. You can join that in real time as people are clicking on your website, find out who that customer is in real time, and filter for a certain type of customer, and go and write that out to a separate stream of data. Maybe that's going to feed into an operational dashboard. It could feed into an event-driven application that says, when an important customer comes to our website, go and page someone, tell them to phone the customer and make sure they're happy, or something like that. But the point is, we're joining live streams of data to other data that we've got in our systems. So some of the problems that Kafka solves, let's have a think about that, because then that lets us get an idea of how we can actually build on that architecturally. The kind of thing that Kafka is great for is helping us with our event-centric thinking. So I talked before about all data is events. Even stuff happening in databases is actually events under the covers. So if we think about this, we've got a bunch of stuff happening on our web application, maybe we've got a bunch of log files coming from it, and we want to analyze those log files. The way that some people would approach that would say, I've got a web application, I've got log files, I'll stick it in Hadoop and run some Impala type stuff on top of it, okay? Web application, Hadoop, fine, we're done, we've solved that problem. The problem with that is we're thinking about log files and we're thinking about Hadoop. We're not thinking about the events. Because the events are, someone viewed something on our website. That's the event. So if we emit that event to Kafka, and then we consume that into Hadoop and say we'd like to analyze that, now we can actually evolve things. Now we can say, turns out it wasn't just our website we were interested in. Turns out when someone launches a mobile application, or we open that API out to the third parties, and we also get product view events from them, that event goes to the same Kafka topic, gets consumed the same downstream. If we don't have Kafka in that picture, each new event producer now needs to know, where do I need to send that to? Or Hadoop needs to know, where do I go and get that from? And soon you've rebuilt that spaghetti picture I showed you earlier. The same downstream. We have applications that are interested in events. Hadoop's interested in the product view event, but so is our security team, so is our recommendations engine, so is our monitoring team. So they just subscribe to the events topic. They don't need to know that they go against the web application or the mobile application or wherever else those events might come from. It's just an event. So Kafka helps us out here in decoupling the sources of data from the targets of data. Kafka also helps us out simply in building systems that are more resilient to failure. If we're simply chucking data from our source to our target, or we're pulling data from the source into our target, push or pull, whichever way, if one bit goes offline, the other bit's stuffed. Now we need to set up retry logic and so on. If one bit can't keep up, if the target can't keep up with the rate at which the producer's producing data, we're going to start dropping it. Or we have to start caching it here, or we throttle what's going on here, which is a bad idea. So by putting Kafka in there, it comes back to the events. We produce events at the rate at which they're being produced. If our consumer goes offline, no biggie. Producer just keeps on producing data. Kafka buffers it. Kafka persists data, remember? When our consumer comes back online, it will just pick up where it left off. It will go back to the point in the log from which it last read, and it will just keep on reading those events through to now and then on into the future. We don't have to have some nasty restart semantics in there, like when it comes back online, you do this and then stand on one leg and then switch back over to the live stream. Okay? Kafka also lets us handle varying consumption requirements for data. So let's say we've set something up, we've got a direct feed from our producer. Our consumer says, I just need to know this data once a day. I'm good with batch. Why would I want any more than batch? So it does a 24-hour batch extract. All good, it works. But then another application comes along and says, I would like that same data, please. So we say, oh, it's all right, we've got the data sat over here. We don't want to hit the producer twice, because then we'll be hitting it twice and annoying the DBAs, and you don't want to annoy DBAs. So we've got the data, we'll pull it in there. But the problem is we need that data in real time. So now we do have to annoy the DBAs. We have to pull it out from there, because we pull it here in real time, because the existing system is pulling it as a batch extract over there. So we say, well, that's not great, is it? So why don't we change our consumer over here to do its 24-hour batch extract from there? And now we're only hitting this one once, and all's good. Well, no, all isn't good. Because now we're tightly coupling A and B together. Whether B pulls from A or A pulls from B, they're now directly dependent on each other. This isn't about events. This is about like systems and implementations. If we use Kafka, we produce the events as they occur into Kafka. If you want to read those events once a day, fine, be my guest. They'll be sat in Kafka persisted. You can read them as soon as you want. Or you can come back online once a week and read what's happened in between. If you want that data straight away, you can also do that by pulling it real time from Kafka. But you decouple those target systems completely. And you also only have the data coming out of the source once. Kafka is also really cool for letting you evolve your technology in a kind of a very flexible and relatively risk-free way. Well, not risk-free, but you mitigate some of the risk. So you've got a standard pipeline that you've set up. There may be kind of like a dozen different consumers, but we're interested in just one here. Maybe we're dumping data out to Elasticsearch, for example. We've got stuff happening in our source. We're streaming it out to Elasticsearch. We're doing some nice analytics on top of it. And then a new version comes along, but we're not quite sure if it performs how we think it does, or we're not quite sure if the extract mechanism is going to behave. So we run it side by side. The benefit here is that the new version we can actually refresh with a full state, because we've got the event log, we can rebuild the state into our new version. We keep on streaming new events as they come in, so we check that, does it perform the same, does it behave the same? And then we can actually do side-by-side checks here, does what's in there match what's in there, because we know the source input's the same, because it's all come from the same place. And then we're happy, we switch over to that one, the other one just goes offline, and you'll notice in all of this, we've just kept on producing events as we did before. The same thing happens with if we have, maybe we're doing machine learning scoring. We've got a machine learning model, we've trained it, we're scoring real-time streams of data as they come through. We've got a new version of the model that we want to try out. Do the results come through, are they more accurate, and so on, run them side by side. The key thing here is it's the same stream of data. And then as we say we want to switch over or not, we can cut over to it without impacting other parts of it. So these are some of the things that Kafka does for you. These are some of the problems that it solves. Now let's think about some of the patterns that you can actually build out with Kafka. One of the key things around Kafka, certainly from my point of view, and I've probably got a bit of a biased view on it, kind of given my history with analytics and stuff, and kind of integrating systems, is it's about putting in place a platform on which you build. Like I gave the example earlier with the event-centric thinking, and the idea I've got web logs, I've got Hadoop, why don't you just connect them together? That's fine, and that solves your problem today. But next week, when you want to switch from Hadoop to S3, you're hosed. You're back to square one. You've got a new project to do, instead of let's just hook up a new connector. So one of the things about Kafka is as a platform on which you can evolve your architecture, particularly with things like new technologies and Hadoops and S3s and whatevers. Things don't stand still. It's not like we're going to deploy this and we're good for 10 years. You're going to deploy this, and if you've got any sense, you're going to say, well, yeah, we'll try that. No, no good. We'll try the next one, or we'll run them side by side, because the technology moves at such a rate. The other thing is around the coupling. If you tightly couple your systems together, they are super inflexible, because now you are directly tied to what does this one support as a target, or what protocol can we use to integrate with this one. Or we've got these three that are all hooked together, and we want to change that one, and now we have to change the other two, and we don't do that because blah, 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 blah. So Kafka lets us decouple those things. So probably the simplistic use of Kafka, the simplest, rather, use of Kafka is just as a dumb pipeline. So taking data from a database, streaming the changes in real time into Kafka, streaming it out into somewhere for analytics. So it could be HDFS, S3, BigQuery, wherever you want to put it. It could actually just be another database. But the point is, we're integrating sources of data. Could be one database, could be 100 databases, could be the same type of database, could be a bunch of different software. You've got data flowing into Kafka and then being kind of consolidated at the other side. But actually, Kafka can process data. So doing this, probably over here, we're going to start writing some transformation jobs. If you think back to those opening slides where I was talking about, like, you copy the data across, and then you're on your transformation. So this is what lots of people end up doing. Stream it into HDFS, and then write a Spark job to take our lovely real-time streams of data, and then sit and wait, and then process it. Whereas Kafka has got stream processing capabilities. Kafka could actually do that enrichment on the data as it passes through. Let's say we've got data that's sat in a database. We want to use something like Elasticsearch. So Elasticsearch is fantastic. It's kind of like it's a document store type thing, but you can basically chuck data at it and do great analytics with Kibana on top of it. Super easy. But it really doesn't like normalized data. It really needs it to be normalized for you to be able to use it easily. So this is a perfect use case for Kafka. You've got data sat in a relational database. You've got your fact, you've got your dimensions. You stream those in real time into Kafka, use Kafka's stream processing capabilities, use KSQL. It's just a SQL statement. Select this, comma that, left join that, done. And then you stream it out in real time to your target. Again, the advantage of that, and that's pretty cool in itself, but the advantage is that you're starting to decouple where the data is coming from and to. So as your application evolves, instead of data coming from the database, now the data is coming from a mobile device or some such. But the point is the data is coming from somewhere else. Maybe it's a different database. Maybe it's an application producing it directly. But we now have a stream of data coming from somewhere else. We have our reference data coming from a database. Kafka still does its joining thing, because at the point at which the data is sat in Kafka, it's just streams of data. We don't care where it came from. It's just streams of data. And then downstream, completely unimpacted. We've still just got enriched order information. The thing about Kafka is that it's not just about an end-to-end pipeline for one purpose. The thing about Kafka is it's a platform for unifying what you're doing across the organization with data. Because the same data that you want to know about for analytical purposes, who ordered something, is also going to be useful elsewhere. Perhaps you want to write an application that's going to be driven by someone's placed an order. So the old way of doing things would be to say, well, I've got my order system, I'll hook in my application directly to that, I've got my analytics system, I'll hook that in directly to that. We're back to spaghetti. Whereas actually, if we use Kafka to send the events to as they occur, we can enrich them for analytical purposes, we can enrich them and use that same enriched data to drive another application that wants to know about it. So instead of performing the transformations in different places or cleansing the data in different places, we cleanse the data once as it passes through, and we can use it in multiple places. We can use it for analytics, we can use it for driving applications, we can even go and write it to HDFS for long-term audit or kind of data science-y type batch analytics. But it's the same data. We can use Kafka as the broker in a microservices context. So for linking together different microservices that we're building out, as a means for exchanging information between them. And because we're using Kafka, Kafka can integrate with existing systems, and it can also integrate with downstream analytical systems, like we saw with something like Kafka Connect. If you're interested in more of this, there's a great article my colleague Ben Stopford wrote on our blog. In fact, a whole series of articles all around this. So I'd recommend you go and read those. So you can build out new microservices systems, like completely greenfield, using Kafka as your broker, and that's what some people do. But you can also use Kafka's integration capabilities to take existing systems and use events from existing systems to drive new ones. So you have an existing CRM system, it's a black box system, you're not allowed to change it, or you're allowed to change it, but you don't want to because it works just fine and you don't want to touch it. You can hook that up to Kafka, take changes in real time, and use it to start building out new applications around it. So you've got your existing application, it's almost certainly got a database sat underneath it, change data capture into Kafka, you build one new application, a microservice driven by those events, you build another one. You can use stream processing also to do the filtering as you need to. But you can actually start to evolve from old to new without actually impacting those old systems at all. Who remembers this slide? Who is awake? Who is awake? Hands up. Most of you, okay. So, like I say, I did this talk last week and I put this slide in, mostly because I like the picture of the dog, but also because it illustrates this idea of batch being latency built in by design. Okay, batch is how we've always done things, so we assume, well, we'll just keep on doing batch unless someone tells us otherwise. Unless someone tells us, now you need real time, we'll just do batch because batch is what we're used to. But I'd like to challenge that assumption. Just as I would challenge, I must use a database, often but not always, I must use batch. Why? Why must we use batch just because we always have done? So anyway, that was what I kind of put in there. Someone tweeted it, someone picked it up, and replied this. You say that latency is a synonym for evil, which I thought was kind of like quite interesting. And I replied to the guy online and had like an interesting conversation. But I want to explain why I have such a hang-up around batch and latency. So latency matters because what we're talking about is integrating systems here. We're not talking about, here is my use case requirement, I'm going to build this end-to-end, and it doesn't say real-time on the spec, therefore I'll do batch. That's not how you build a flexible system that's going to scale across your enterprise. So last week, I went to Switzerland for the first time. It's a lovely place. I strongly recommend it. And at the airport, I bought a bottle of water, and I got a notification on my phone saying, you've been ripped off. It cost £5.70. But it was kind of useful anyway. And then they said, well, your flight's boarding. So these are push notifications to my phone. These are kind of useful. I have no idea of the systems behind them, but I'll speculate, probably entirely wrong, that that's just a system somewhere where someone said you've got a bunch of transactions going on, do a push notification out to the user because that's useful, which it is. But this could be like a siloed application that happens to do some real-time notifications. And within our organizations, we've done real-time for years, but kind of like in this little bit of the organization for this little particular use case. Everything else is batch. But then I landed in Switzerland, and my bank said, welcome to Switzerland. Thank you very much. The exchange rate is this. So now we're talking about data around my location, which presumably comes from my mobile phone, being combined with data from what's the exchange rate. And then I bought a train ticket into town, and similar transaction notification, but this time they said, well, this is what it costs in your local currency. And they've obviously know what Bundesbahn is because they looked it up in their database and said, oh, well, here's your silly little train emoji. But the point is, now we have data from other different systems being combined. So the exchange rate, the location, the transactions, all of these things come together to drive a real-time application like that. When I go and look at my bank account, it says, here's what your account balance is, here's your different transactions, as of a few seconds ago. This is not like bank accounts as of 10 years ago, 5 years ago. Here's your monthly statement in the post. Okay? Your monthly statement in the post is batch is fine. Okay? But me as a consumer, all of us as consumers with our mobile devices want data that's right as of now. Every time you unsubscribe to a system online, it says, thank you for your whatever, we will update our systems. It may take 7 days to update. It's like, you guys are doing batch. But actually, I'm going to be annoyed if you send me an email now, because I've told you now already I don't want them. And that's why real-time matters. So that's why latency matters. It's not about this particular use case here doesn't need real-time, so therefore screw it. It's about an event has happened. So get that event out there, low latency in real-time, and then applications that need it can do so. Applications that don't need it can use it when they want to. So make your events available as soon as they occur. And then your consuming application can use it when they want to. But driving it the other way around, that's like cart before the horse. So is latency evil? No, but it's a bit of a pain. So, to conclude, analytics and Kafka. I kind of opened with this idea of like, why do we need a streaming platform? Because we have the old ways of doing things, we have more data, we have the need to actually bringing things together in real time and integrating systems. And like I said, I used to work in analytics, and there was this thing around one version of the truth. So hands up, analytic-y people, who recognizes this? A few of you, yeah? So this idea that across your organization, you've got dozens of systems, if not hundreds, and probably a tenth of those all have an opinion over what was our profit margin, or what was our sales last week. And it depends on how you count sales, and so on and so on and so on. So the idea in the kind of the world of analytics was that you would have one version of the truth. You would get people together in a room, you say, this is how we define it. We will now build our systems and bring them together, and angels will sing, and we will have a single answer that we can report to the board as one version of the truth. What actually happened was that we still had people trying to do it. Okay, let's pretend it's that one up there. But then we had a bunch of other people with Excel and SQL Server running under their desk and maybe a cloud instance on AWS saying, that one version of truth, either I don't buy in, or it's taking too long to deliver, or actually, screw it, I'm just going to do it my own way. So you end up with all of these different systems pulling data from all these other different systems. You have sales data going all different places, you have warehousing data all these different places. All of those different places are doing their own transformations, and so also saying, oh, you've got that bit of data, can I use that bit, and then I'll pull it in from here, and so you end up with this spaghetti problem. So the pragmatic approach, I would suggest, and this is where the kind of like the title of the talk came from, embrace the anarchy. You're never, ever, ever going to avoid that. You can have the best will in the world, the best steering committee, the best competency centers, whatever. You will never avoid this problem. So I would say, well, embrace that. You will always have this anarchic approach, okay? Because a lot of that is a people problem, okay? And unless you fire everyone, you're always going to have a people problem. So the pragmatic approach is say, well, okay, we're going to have one version of truth. We are going to build that. We're not going to lose hope. But we're going to recognize that other people will also do their own things, rightly or wrongly. Who are we to say? We're going to use Kafka. We're going to use Kafka as events happen in our source systems. We're going to stream them into Kafka. We're going to do our data transformation in real time using Kafka's stream processing capabilities. We're going to feed the downstream one version of the truth. And if anyone else wants to come along and use that data for their own little dirty solutions, they're welcome, the data's there. The cleansing and transformations that we've done for our proper solution, they can use. And actually now we benefit because instead of them going to the source and doing their own transformations, and I think you do gross profit like this, they'll actually have that enriched data already. So hopefully they'll actually just use the right data anyway. And then, of course, because we have those events coming from those source systems for analytical purposes, those same events can be used for driving our machine learning processes, for our graph databases. We can stream out to search databases. We can build event-driven applications. All of this can kind of be driven through Kafka as the platform. So this is where actually analytics and operational applications come slap bang together. Kafka is a platform across your business. It's not just a big data technology for analytics. It's not just a messaging queue. It's actually a streaming platform across your business. So like I say, I work for Confluent. Confluent, like the company, we have a distribution of Apache Kafka. Confluent open source does all of this stuff that I've shown you. So it's a free download. It's free forever. It's not time-bombed. There is no catch. You get all the connectors. You get the client libraries. You get KSQL. You get a whole bunch of really good stuff. It's built on top of the latest version of Apache Kafka. You can ask me about the Orange Enterprise stuff afterwards if you're interested. If you want to know more about Kafka, there are some excellent books you can get for free from our website. And these are not kind of like Mickey Mouse marketing things. These are like seriously good books. And finally, that's where you get Confluent Platform from. There's a really good, vibrant Slack community. There's different channels for all different sort of subjects. That's my contact details. I'll hang around now. I think we've got 20 seconds for questions if anyone wants to. But if you do have any questions, please do feel free to reach out either on Twitter or there's my email address there. Thank you very much. Okay, going to the next thing, or ask questions if you want to. Any questions? Yeah.
What protocols does it support for transfer of data?
Say again?
What protocols does it support?
So the question is, what protocols does it support for transfer of data? So Kafka has Kafka Connect API, which is a framework, an open API, and that has various plugins. So there will be a plugin, for example, for HDFS, for sending data to HDFS. There is a plugin for JDBC for connecting to a database. There are plugins for CDC tools. So Kafka Connect is one of the ways of doing it, or you have the producer and consumer APIs for your own applications to integrate with it.
So you mean to say it's kind of adapters when you say it's a plugin, is it adapter?
Correct.
To directly connect to that system?
Yeah, so if you're using Kafka Connect, you would have, and we call it a plugin, but an adapter, which is something that someone has written using the Connect API, along with the APIs of the source or target system to do the integration. That's right.
You mentioned that Kafka does some enrichment when it writes to its log.
Yeah.
What kind of enrichment does it do?
So the question, I think, was what kind of enrichment is Kafka doing when it writes to the log? So Kafka can simply pass messages through, but everything that goes through Kafka, as how Kafka is designed, is written to this event log. It's an immutable event log. If you want, you can use stream processing capabilities in Kafka to do your own enrichment and say, derive this column, or do a join from this other thing, or aggregate, or something like that. So that's up to you how you use it, yeah.
By default, there's no enrichment.
By default, there's no enrichment, no. By default, it's just data in, it's just bytes in, bytes out, yeah. It's key value pairs with like timestamp and headers. Yeah. Yeah.
You spoke of connectors. You use connectors to different stuff. How good are they dealing with really legacy stuff like SFTP and FTP?
So the question is integrating with legacy stuff, basically like SFTP. So there's a bunch of, so Confluent has various technology partners, including like Oracle, they've got Golden Gate, which supports Kafka and Kafka Connect. There's Attunity, there's SQ Data. There's a bunch of technology companies, like SQ Data, for example, and Attunity specialize in like mainframe, so like IMS and VSAM and stuff. For SFTP, I think there's a Kafka Connect plugin. So Kafka Connect has got plugins that ship with Confluent open source, they're free. There's Confluent Enterprise for things like JMS and IBM MQ and so on. And then there are plugins from technology vendors, and then there are community plugins. So it's an open API, so anyone can write one. So like, there's a ton of like Java, Twitter plugins, because everyone uses Twitter as their example. I think in that category of like community ones, there'll be, there's SFTP and FTP as well. Yeah.
In terms of summary data, like the example you gave on the calculations, does that condemn to keep the event history forever? Or is there some kind of summarization that would avoid keeping that history for absolutely ever?
So the question was, in terms of summary data, do you have to keep that, the source events forever? My understanding, and I could be wrong, is that the aggregates that you persist within Kafka, if you're building a stateful aggregate, that source data, those source events must still be there. And as the source events are timed out, the aggregates themselves will become invalid. But you can persist data in Kafka for years, if you want, or indeed forever. And there's something called log compaction, which I didn't talk about, but you can keep it as long as you want to. It would then come down to why. Like, why do you need to maintain that state, that aggregate in Kafka? Because you could still take the event log and use that to rebuild it elsewhere in a database or in a document store or something like that. So it depends on the particular use case. But in a nutshell, if you want to persist an aggregate, you have to have the source event as well. Okay.
Is there about the real-time updates? So will Kafka push the updates to the consumer, or will the consumer require to pull the updates?
So for real-time updates, if you're using the consumer API, it will poll Kafka for any new messages. If you're using the Kafka Connect, it will push out any new messages from a Kafka topic down to the target system.
What happens when it goes down? What are the redundancy strategies?
So the question is, what are the redundancy strategies? What happens when it goes down? So Kafka is a distributed system. So you can set it up so you have multiple brokers, and you can set a replication factor on your data. So you can say, I want to have 7 replicas of this data, i.e. 6 redundant ones. So if you just lose kind of like one box, no problem, the others will pick up. If you lose an entire cluster, then you would, or if you're worried about losing an entire cluster, you would want to use replication technology that's available as part of Confluent Enterprise. There's also an open source one, in my opinion, less functional, which lets you replicate Kafka clusters. So typically this is what people will do if they have multiple data centers. You'll have a Kafka cluster in one, using real-time replication out to the other data center to maintain a copy over there. Does that answer your question?
Yes.
Not entirely.
Yeah, if you work in a very, very time-sensitive environment, how are you going to switch from one of your instances to the next one?
So within a cluster, the consumer, and I'm on slightly shaky ground here, so by all means contact me afterwards if it sounds like rubbish, but in principle, within a cluster, the consumer will know which are the brokers that have got my data. So if one of them goes off, sorry?
It's behind load balancer.
No, you wouldn't necessarily use a load balancer. So the Kafka technology knows you have something called in-sync replicas. So each of the brokers will know which partition do I have, and therefore the consumer will be able to pull against a particular one, I think. Feel free to drop me a line and I'll get you a more official answer. Or even better, come along to the community. That's my handle on the community. And there's a bunch of my engineering colleagues there as well who will be able to put me straight. Yeah.
Are there any security mechanisms?
Does Kafka have a security mechanism? Yes, it does. It has access control lists built in, so you can use Kerberos. And then Confluent platform has got a bunch of other security bits around it as well.
Storage is embedded or plugged in any database?
So the storage in Kafka is part of Kafka. Yeah. So even if you wanted to, you couldn't use a database because that would be a bad idea. So like one of the reasons Kafka is so fast is that it writes to its log file, and then most of the messages end up in the operating system page cache. So then the consumer is generally pulling it out of that cache, i.e. memory. So the log file itself sits on disk. If you're worried about the data sensitivity, you could use local encryption on that data with a third-party tool.
Is it tunable?
Is it?
I can tune it or configure it.
You can tune it. You can do what the hell you want with it. Yeah, it's open source, so you can really screw it up if you want to. And then there's like tons and tons of settings. Whether you should do or not is a different question. Oh, okay, sorry. Last question, and then.
About the deployment, is it on-premise or can it be in the cloud or it doesn't matter?
So the question is about deployment. So you can run it on premises, you can run it in the cloud. There is Confluent Cloud, which is a managed hosted version of Kafka as a service on Azure, Google, and Amazon, Google, and soon to be Azure as well. Any more questions, come and speak to me or send me an email, please. Thanks.